To AWS She Builds Tech Skills with your hosts, Maya and May.
Welcome everyone to Season 3, Episode 1 of AWS She Builds Tech Skills. Now, we are going to have an awesome session today. We'll have a really cool guest from Mantle Group today. We'll introduce her in just a second, but I'll talk about what's been happening at the AWS space. And we have our co-host here, who is Jyoti. Welcome, Jyoti, our awesome co-host.
How are you?
How are you? Yeah, very good, thank you. What's been happening that you'd like to talk about? I see you've been involved in a couple of AWS events. I saw on your LinkedIn profile. Would you like to talk a little bit about that?
Yeah. So most recently was the AI Cloud Day in Auckland, which was a fast follow-up to the Observability Day that we did, given our theme. So we did have a very successful Observability Day in Auckland in July, and we spoke about app signals. So if you've not heard about CloudWatch application signals, which helps, it kind of provides an opinionated view of what good could look like for application performance monitoring, and how you could have your dashboarding set up for faster correlation between your traces, logs, and metrics. So that was a big highlight for most of the customers from that day. And then, based on the success of application signals and given the Gen AI hype, also launched a blog post on improved application visibility for generative AI applications built on Amazon Bedrock as well. So, yeah, all in the observability world. So I don't know if everyone knows how things work at Amazon. We have TFCs, we call them technical field communities, and I have a keen interest in observability. So I'm really excited to be here today as well with to talk more about observability on AWS.
Awesome. Thanks, Jyoti. It's awesome that you're part of the observability community group within AWS. And yeah, today's theme happens to be all about observability, especially around Amazon EKS. One of the cool events that I was part of was the AWS Financial Services Symposium in Sydney. So I had the pleasure of helping the AWS training and certification team talk about, did we talk about observability? I could have been in there, but I'm sure that, the focus is on generative AI, as you mentioned. There's a lot of talk about generative AI. And, we do have a lot of tooling around, leveraging that machine learning behind the scenes with some of our observability tooling. So there's a lot out there that we can leverage for our customers. So, yeah, big topic. Let's talk about it. But before we do talk about that topic, we're going to introduce our guest today, who is Christina. She's from Mantle Group, and she is an SRE, or Service Reliability Engineer. So welcome, Christina, to the show. Hey, Christina.
Hello, Josie. Hello, Mai. Thank you for having me here.
Awesome,
Hey,
awesome. Would you like to talk a little bit about yourself? I mean, we've got a few questions, but before we dive into the questions, can you introduce yourself?
Yeah, absolutely. My name is Christina. I'm actually a SRE, currently working at Mantle Group. For some people may not know, SRE is Site Reliability Engineer.
Yeah,
always
awesome.
a big fan of women in SRE roles, because you don't find too many of us. I used to be one in a past life, so really a big fan. So yeah, really nice to be talking to you and about, and also observability, very close to my heart. So yeah, really cool.
Yeah, awesome. So a couple of questions, I know you kind of pivoted from a different role before. Why did you change your career midway? Love to know.
Yeah, so I used to work as a ICU nurse for a decade, actually, and working in Australia. I got a lot of ask about this question. At some point in your life, you realize that's not the thing. It's not challenging enough. It's not exciting enough. You just feel like you want to do something else. At some point, I was pretty lucky. I got other people's career transition journey and inspire me a lot. And I see a lot of people, they transit to tech from maybe teacher, arts, or business, accounting. I just feel like maybe I should give it a go. And today, here I am.
Yeah, that's awesome. Yeah. A lot of people do pivot and go into different roles, and you're an awesome example of that. All right. So, what do you like most about your current role?
For my current role, from the title, probably most of the people already get an idea. Site reliability engineer. So basically, ensure the site always up running. I guess the most interesting part about my role is every day you got facing different challenges. Clients, my role is actually customer facing. So the clients may give you a task saying, I need this, I need that, and I want to be this one in certain time, get it done. So this kind of challenging from maybe you're not familiar and you dig, read the documents and you feel like, oh, I'm pretty confident now. This kind of journey, I guess, really excites me a lot, especially if there's anything goes wrong during my deployment process. Not in production, definitely. And then I feel like, oh, I got something to work on. I guess that kind of thrilling makes me realize, this is the thing I have always want to be involved.
Wow, that's so impressive, Christina. I mean,
you.
typically what I see with when people do actually have career change is they probably get into a testing role or they get into product ownership roles. The SRE one is very interesting. Did you look for it, or did you just happen to fall into the SRE domain?
Yeah, it's also an interesting topic because initially I was a DevOps engineer in my previous role, and I got opportunities to migrate project from end to end. And after this project migrated, I landed in SRE role, and I found it quite interesting. And then I just keep continuing go further.
Right. Oh wow, that's really cool. Very impressive. Yeah.
Thank you.
Yeah, and love to know, what do you do on a day-to-day basis as an SRE?
That's also very very good question. I want to talk about SRE as SRE. It's a very customer-facing job. So in my role, we have operations work. So basically, if a customer have any feature request saying we want to push this change to prod, and we are gonna ensure the whole pipeline deployment is not broken and always in a robust place. Also, we have some DevOps as service kind of customers, which means we got to able to we have some managed service customers. Sorry, we got to be able to handle all the alert notification incident. We go to like a P1, P2, P3, P4, so that we go to have the opportunities to troubleshooting what's the issue underlying. And when you do the troubleshooting, it's actually challenging your knowledge a lot. You know the thing, you can't just know the surface. You need to go to deeper to understand why. I keep asking why, and go down the deepest and then understand. And then you see the gap, like what you know, what you don't know, oh, what I know. So this part is very interesting. Apart from this, my current team also have some internal projects. So basically, if you see some internal projects, there has a part you are interested, you can work on that. It's kind of a part of a continuous learning.
Yeah, it's all about continuous learning, isn't it?
Yeah.
Yeah. Jyoti, can you relate to what Christina was doing in your previous role?
Yes, absolutely. And some of my favorite parts of being, a site reliable engineer, like being on call, was the incident response. When you actually have an incident, there is no feeling like the one that you get when you are all together. The whole team together comes together and tries to solve that problem because you want to ensure that you can resolve it as quickly as possible. There's no egos, there's nothing, everyone's got just one goal. And that used to be one of my favorite parts of the role. But after that, the retrospective, I guess, the incident retrospective was the next part, because you learn so much more from that as well in the incident retrospective on how you can do better the next time. So yeah, those were the two parts that I really enjoyed as well. Yeah.
Yeah, awesome. All right, so let us move on to your topic for today, observability on Amazon EKS. So over to you, Christina.
Okay, cool. Let me start share my screen.
All right, while she's sharing the screen, just curious, the audience, if you have any questions for Christina during the session, please put it in the chat. And yeah, is anyone interested in an SRE role, or maybe you're already in an SRE related role, or you're an SRE yourself? Yeah, put it in the chat there. Love to know.
Yeah. Or also, if you know about EKS, if you've used EKS, if you're one of the users of EKS, or you're completely new, yeah, just let us know so that we can know where you're at in your EKS journey, and how you find observability for EKS applications. That's another part, because that's where we're here to learn from Christina, or hear how Christina solves that.
All right. Yeah, we've got your screen shared. Over to you.
Okay. Thank you, Mai. Thank you, Josie. And thank you for the audience who attend this session. Today, I'm really excited to share one of the key topics around my work is Amazon EKS observability. So today's session, we are going to cover observability pillars, architecture, Amazon EKS observability best practice. We are going to have a quick demo, and in the end, we'll have a Q&A. First and foremost, I want to talk about why is observability important. Kubernetes allows customers to build containerization applications, but when things goes down, we need to troubleshooting what's the issue and find out the logs to be able to react and respond as early as possible and get notified immediately. With observability in place, we can actually detect the issues, investigate what's happening there, what's the root cause, and remediate the risks and vulnerabilities so that we can have a reliable system, which matches to my title. Then what is observability? Observability is our approach, can ensure monitoring, logging, alerting, and tracing in the whole system. Monitoring the metrics for the application performance, collecting the logs for the troubleshooting, get alerted when things go abnormal, and tracing the API requests from end to end. Then in our today's topic, what are these services in observability? Now let's look at this diagram. Here we have the Amazon Elastic Kubernetes Service, which is short for EKS. It's a Kubernetes cluster running on AWS. We will come back to this diagram later. Now let's look at Amazon CloudWatch logs. CloudWatch logs is to centralize all the logs. It's good for us to troubleshooting. It also supports for run query. Amazon Managed Service for Prometheus. We also short for AMP. It's a fully managed service compatible with Prometheus. It allows us to monitor, collect the metrics, and configure the alerts to receive notification. AWS X-Ray is also a fully managed service. It's a tracing service which can collect the API requests when the requests are traveling through the application. It helps a lot with engineers analyze and debugging. All these three services can be configured as data source for Amazon Managed Grafana, which is short for AMG. This service allows us to monitor and visualize all the metrics in certain period. Also have a feature allow us to explore the logs for troubleshooting, and we can send the alerts, integrate with other notification service. In today's topic, we have Amazon Simple Notification Service, which is short for SNS, so that we can get notified.
Christina, so I have
Yeah.
a question. So, you mentioned that, you've used Prometheus for the metrics. So CloudWatch also has metrics. So can you talk us through why you chose Prometheus over CloudWatch metrics in this particular case for EKS observability?
Yeah, absolutely. So initially, CloudWatch, EKS have an add-on called a CloudWatch Agent. That one, it also allows us to collect the metrics, and we can configure CloudWatch as a data source to the AMG, so that we can have all the visibility. But in my case, I use AMP because I used one of the customer managed collector. I will show you guys in the next slides what's exactly what he's doing. In today's topic, I use the ADOT collector, one of the customer managed collector, because we have some open source the repo we can use directly. That's one of the main reason. And also it's quite, it allows us to integrate with other third-party services as well.
Yeah, and I think one more reason that typically what I've seen in my experience with customers using ephemeral workloads like say ECS, containerized workloads basically like ECS and EKS. Prometheus has better support for that particular case. Like for example, with CloudWatch, if you had a container-based metrics being shipped, the number of dimensions that CloudWatch supports, it doesn't allow aggregation across the container level, but Prometheus has that support for those workloads where it's the same application on multiple different containers, but Prometheus has better support for giving you that cross application, or regardless of what kind of container it was running on, it gives you that ability, that flexibility, better flexibility. So that's where many people choose Prometheus for ephemeral workloads or other containerized workloads as well. So yeah, it's a good choice. I was just curious in your case if you had the same observation.
Oh, I see. Thank you for bringing this up. Let's come back to the Amazon EKS, this diagram. In today's topic is about Amazon EKS observability, which actually we're gonna explore a bit. What is EKS? Here we see two planes. One is EKS control plane, which is known as master node. We have SCD, which is key value store. We have the cloud control manager. We have API server. We have a scheduler. We have a control manager. And for EKS data plane, which is also referred as work nodes, who is actually running the application. We have two nodes here, node 1 and node 2. Let's start node 1 as an example. For each node, we have a kubelet, which is kind of like a captain of the node. It's talk to the API server. We have the pods running the application. We have the kube proxy. We can manage the network rules. We also have these objects. So regards to the observability, it's about the control plane observability. It's about data plane observability. Now let's go have a think. How this EKS observability get set up? Who is doing the actual job? Let's look at this diagram on the high level first. From left to right, first, we use a Terraform as an infrastructure as a code tooling to provision the whole observability stack. And whenever there's a new code commit, Flux CD, which is one of the application, gonna pull the change. And control manager in the last slide, gonna compare what's the desired state, which is in the code, and the current running state, which is what's the running in the pod. When the whole stack set up, we grant certain users to be able to have the access, view dashboards, and certain users and groups to receive the alerts. Now let's go back to who is actually doing the job. We have an Amazon EKS cluster here. In this cluster, we have AWS distro for open telemetry. We also call ADOT collector. It's a customer managed collector. We configure this collector to be able to collect the metrics, trees, and pump into AMP and AWS X-Ray respectively. For logging part, we deploy the Fluentbit to collect all the container logs and push to CloudWatch. On the cluster level, in order to collect the kube events logs, we have deployed a Kubernetes event exporter and a Victor to be push the logs to CloudWatch. Grafana operator allows us to create all the dashboards as required on the UI. And for the secrets, we use external secrets, which is be stored in AWS System Manager Parameter Store. Once all this is set up, we will be able to see all the metrics and the logs and run query in the Grafana UI. So next question is, how do we know our observability is setting up correctly, right? How do we know we are doing a good job? Luckily, we have AWS Observability Best Practice Guide and AWS EKS Best Practice Guide here. When your application actually running the cluster, you want to monitor what the performance looks like. Is there any issues? In that case, do we want to monitor everything? The answer is no, because it can be very expensive and also it's not the best practice. We only want to monitor the key metrics matter to our application, especially related to golden signals, which refers as latency, traffic, errors, and saturation. These metrics allows our IT engineers to be able to observe the application performance and detect the issues as early as possible. But when system goes down, logs becomes very critical. But not all the logs are very useful. In that case, we optimize the logging to be able to capture the meaningful information so that we can troubleshooting, debugging, and analyzing. We set up the log retention policy as per business required, while we also manage the log storage efficiently.
Yeah.
With high stated events like Black Friday, we all shopping a lot, or some unusual activities like unauthorized access attempts. We want to get alerted immediately, right? We want to know what's happening behind. In that case, meaningful alerts and actionable alerts will help us to react and respond as early as possible so that we can stay ahead of our problems.
One of the typical problems that I've seen when, with many of the customers when I've had conversations is, how do I know that this alert is meaningful? Like, should I go in and put an alert on every CPU utilization, and causing alert fatigue? What are your thoughts on that, Christina?
Yeah, that's a very good question. So alerts fatigue is a key thing as a SRE we want to avoid. We only want to get alerted like PagerDuty alerts, like it's a prod, right? We don't want to get alerts if it's a dev environment. For application, if it has dev staging prod, we probably want to get a PagerDuty alerts with prod. And for the staging ones, with the metrics, if CPU utilization goes above 90%, we also want to get a notification, right? So meaningful alerts really helps us to stay ahead of our problem. This is a very good question.
Yeah, cool.
Now let's move to the next part. I'm gonna show you a quick demo. Oh, hang on. Here is my demo EKS observability dashboard on the Grafana UI. We see we have the Kube API server, different types of dashboards. We have the proxy, cluster, workloads, nodes, etc., etc. I'm gonna share a couple of the dashboards and explain a little bit. Let's start by the basic dashboard first.
I guess while that loads, I'll probably ask if the viewers have used Grafana before, what's your favorite dashboarding tool? Mine is Grafana. If you have any favorite tool, do leave it in the chat so that we can know which one you are. One of your favorites.
Mine is Grafana is good. It's been certainly popular with those using EKS. Seems to be Prometheus and Grafana, especially the AWS managed versions, seems to be quite popular. A lot of customers start off with the open source tooling and they want to bring it over to the AWS side. So that's why the AWS managed Grafana, Amazon managed Prometheus, and ADOT or AWS distro for open telemetry is a good choice.
Yes.
Yeah, Grafana is kind of my preferences in the observability. It really have a lot of feature and have very beautiful like dashboards. Whatever the dashboards you want, you can have a look from the template first, and then you go to modify your code.
Yeah. Looks like the audience agrees with Grafana. So Liquid Furrier said Grafana as well. So
So and also, sorry, you go, Christina.
Oh, thank you. And also, I was trying to say they also have a very big community there, and also with AWS managed Grafana, it has integrated with AWS, and it's easier for us to manage the access on the granular level as well.
Yeah. And I just wanted to add on the Grafana side, at Sydney Summit, where I built the resilient, I contributed to the demo build of resilient systems. And we used Amazon managed Grafana, and everyone who came to the booth came because of the Grafana dashboards. They didn't come to know what resilient systems was. They actually came because of the dashboards. It's a very powerful visual medium. I think it just talks to the fact that we're all very visual. Majority of us are. And so they all that was the huge draw card, where then, as to your point that you mentioned, that you can template it and deploy it, everyone was like, can we get this template? Can we get this template? That was the constant question. So it was I think Grafana has quite a good following, but it's also a powerful dashboarding tool. So
yeah, especially with integration with AWS, we don't actually need to manage the underlying infrastructure. That's why I choose the managed managed Grafana instead of provision the Grafana pod in the cluster.
Yes, and I think the recent update that we had on Amazon managed Grafana, where now you can bring in any community plugin. Like until earlier in this year, they actually had guardrails around what kind of community plugins could come in. But now they've opened it up. You can bring in any of your plugins. And I see there's a question in the chat. So Christina, maybe if you want to take it. I think it's on the screen now. Is there a way to annotate Grafana dashboards?
It's a way to, sorry, what?
Annotations. You know how you can add annotations to kind of highlight specific incidents?
You mean getting alerts?
Yes, like adding a comment. So like as Surya has said, like you can add a comment. Like I've done this, so you can do it on Grafana. The answer is you can do it. So basically, as you are here, if you do a right click, depending if you have permissions or not, I think you should be able to do add annotation if you do right click. So basically, it gives you that visibility of as you're looking at the graph, like let's say during an incident, or maybe you did a deployment, you could then trigger an annotation to be created on Grafana via HTTP. And that would create that annotation, which when someone else said, as you know, with SREs, there is the roster. And so say to like you deployed something, so there was some wiggle in the graphs. Typically you don't want to get there, but if you did have that, you could kind of know that it was triggered because of a action that somebody took, like a deployment action or some kind of update that someone was doing manually. And so it kind of helps with that visibility and faster storytelling, as well as mean time to detect. So yeah, it is possible with AMG as well. Have you used it, Christina? Have you used annotation? It's one of my favorite parts of Grafana.
I haven't, to be honest, but thank you for answering this question, Jyoti.
No, that's all right.
Yeah, I just added in the chat there. Yeah, you can do that in Amazon Managed Grafana as well. So it's there if anyone wants to have a look.
Yes.
Okay, thank you for the question. And I will come back to this dashboard. Let me know if you have any other questions for the ongoing demo. Before I run this, I want to explain the Kube API server. So what is API server in the cluster? For some people know, some people may not know. API server kind of like a door of your house. So when you enter your house, you're gonna go through the door first, right? So the same thing you can think like in the cluster. So basically, API server exposes the cluster to the end user and other services so that whenever the request comes to the cluster, actually is through the API server. Here, I'm going to give a couple of examples of the request rates. What does this mean? If the request rate is very high, which means the API server is handling a lot of the workloads. And if it's too high, it may cause the server respond slow. It's just some the explanation on this. And for API server request latency, if this latency too high, which means the cluster is respond a long time, which may indicate there's some cluster health issue. So all these metrics have a different type of meanings. And I will turn on for the demo and show you guys. We also have a SCD, which is a data key value data store. Now let's look at the troubleshooting dashboards here. We have the port memory and secret cache usage and other metrics. Similar thing with the basic ones, but here by observing the port memory resource usage, if the usage is too high, which means our API server is working very hard to handling all the workloads. If it's too high, which may give the respond slow or sometimes may even crash. So these metrics will be all very meaningful. For the next one, secret cache, we know API server always interact with SCD to retrieve the secrets, and API server store the secrets as a cache. If the usage too high, which may indicate we store too many secrets, and it will consume more memory, give the memory pressure to the API server. So each metrics will have different indication. And by observing the metric in certain period, and we can observe the performance.
So Christina, how do you you mentioned that if pod CPU is high, it means that it's the request saturation is probably high, the number of requests are keeping the server busy, or you mentioned about the cache utilization. Can you tell me what are some of the techniques that you use to know that analyze that, right, and make that correlation? Do you is that by looking at logs and stuff, or do you have any is it by looking at best practice that reading up on the internet? How do you know that, make this correlation, or is this based on your experience that you're sharing this information?
Yeah, that's a very good question. For the API server, if we have any issues with this part, first thing we observe the dashboards to see last 24 hours or certain period to see if the metrics, if there's any spike, when was that? Is there any change, or is there the high, high events time? We observe the metrics, have an idea, then we go to the logs part. For EKS, we have a built-in logging feature on the control plane. We have the audit logging feature and authentication logging feature. Then we can go to these logging groups and go find observe and analyze these logs and go find is there any like different response code or errors. Therefore, we can go analyze and troubleshooting further. And apart from that, we also gonna talk about tracing in the next. We can see how many requests and goes into our application, the distribution system. We can, it's no one place you know what's the issue. Basically, is to combine all the information and go from there.
Right. Yeah. Thank
Yeah,
you.
we've got one question from Liquid Siri again. She's wondering, can we please have the link to the demo dashboards? They seem fun. I don't know if you have this available, or it's maybe a open source solution that you're using. Is it available for people watching the show to leverage?
That's a good question. But for this demo, actually, I provisioned these dashboards mainly for the demo purpose, and I have webbed everything. But if you are interested, I will drop the link how I provision this whole stack in the chat window, or maybe in the I think the she builds the video on the comment area, because we do have the open source, all the code available. All we need is understand and choose what's important to our application and deploy and provision based on what's the IC tooling you prefer. For example, if you prefer CDK, if you prefer Terraform, we all have this open source code there. We just need to modify accordingly.
Yeah, awesome. Thank you so much. I guess Liquid Siri would appreciate that.
Yeah, of course. My pleasure. Okay, I will continue. And here is just show you guys what's the metrics here. For example, we have other metrics, and based on the traffic, we will see the data. On this dashboard, it's a cluster overview dashboard, and basically show us the resource utilization, CPU utilization, and memory, and networking, and storage, etc., etc. In a high level, basically this dashboard are gonna show us if our cluster is overload, and which application is overload our cluster, and if it's underutilized. By observing these metrics, we can observe the cluster health. We can show you here. For example, by bandwidth, by namespace. Namespace, we normally deploy per application into per namespace. And here, the rate of packets dropped. This one related to network. If we see the risk is very high, which means there maybe have a network issue, which is gonna cause the communication between service to the pod. They're gonna have some issues here. So all these data are gonna be very meaningful once I understand what this metrics refers to. For storage I/O here. So basically, this one tracks how quickly the data get read and write to the storage. If the I/O very high, which means get frequently, which means it's heavily used, we can observe this. And if it's too low, which means application trying to get the data from storage takes a long time, gonna have some application performance bottlenecks. Hopefully, my explanation gonna help a bit. We also have the node dashboard. As you can see here, we have 2 instances. By this dashboard, actually gonna show us if the workloads on each node are even. That's one thing. If it's not even, how we can prevent and in our code when we deploy the application. Another thing is we can track the resource usage as well, all from CPU utilization, memory, and etc., etc.
Are you able to share from your experience? So I've not used EKS as much. So from your experience, can you tell me, which of these dashboards? Like, tell me of a scenario where, or a case where you had an issue with EKS, and these dashboards helped you navigate and find the root cause easily?
That's a good question. So for one of my project, actually, so the two nodes, actually, the workload are uneven. One node have 22. We haven't finished the whole application deployment yet. So one of the nodes have 22 pods. Another nodes only have nine pods. And
Right.
basically one of the nodes is, kind of overload, because I remember the disk utilization, disk available usage is only like 10% or something. And then when we look at this dashboard, it reminds me, okay, we need to go back to the code. Apparently the workload is uneven, and so that we know, we need to take action on that part. And by how I resolve that issue is I found a solution. Basically, there's a pod. All of a sudden, I got a memory loss. There's a feature basically in the pod deployment. You can configure, and then the workloads, when the workloads get deployed, it will check on the node resource usage, and when they deploy the workloads, and the nodes are gonna have even workloads, if it makes sense.
Yep. Yeah, it does. I think depending on what you were using for the deployment, yeah, that absolutely does make sense. Thank you for sharing that. That's
Yeah,
useful.
especially when you don't have access to AWS account, these dashboards basically bring your first idea. What is going on if the developers are saying, "Hey, our application keep crashing."
Yes. Yeah. So there, Liquid Surya mentioning Carpenter as well. So yeah, I'm
Yeah,
not sure if
Carpenter is a skill up, skill down. Yeah, that one basically to skill up your if we have a heavy workload and the current nodes can't handle the workloads, and the Carpenter will automatically, of course, based on how you configure the Carpenter, Carpenter will automatically skill up the nodes, and when the workload goes down, and skill in the nodes.
yes.
Yeah, definitely. Carpenter's awesome because you don't have to deal with auto scaling groups. So the old way is to use auto scaling groups and tie that with the Kubernetes native cluster autoscaler. So imagine trying to wrangle so many auto scaling groups with different instance types in there,
Yes.
managing that versus groupless auto scaling, which is Carpenter. So
Yeah.
it gets rid of some of the heavy lifting, as we call it, in the operational space if you're managing Kubernetes. Now, we won't go into a lot of operational management activities that you need to do with any Kubernetes cluster, but that's a topic for another time. But yeah.
Yeah.
Mai is our Kubernetes and EKS expert in-house as well as with customers. So yeah, of course, everyone knows Mai has the gold jacket as well with all the certifications. But yeah, with she's my go-to for EKS. Anything EKS, I go, Mai, please help me.
That's good. In the future, I would like to discuss more about EKS with you guys.
Yeah, anytime. And Jyoti is the observability SME here at AWS. So
Wow,
best
amazing.
of
Good
both
to know
worlds
you guys.
now.
No pressure. Cool.
Yeah. So for the dashboards, the last one I want to share is about how do we manage it for different workload. For example, if we have 100 application running in the cluster, you want to know which one consume more memory, and so that you can manage it and respectively, right? So on this dashboard, for example, we have the filter here, namespace. By deploy different application into different namespace, we can track the resource usage here as well, and network and storage IO as well. So it's a similar, but it's nice to have spare, just a workload dashboard. We also have the other next. Here is about exploring feature in Grafana. I really like this one. I have already configured a CloudWatch as a data source. That's why we can see all the log group here. The current demo is showing the arrow, trying to query the arrow for the last 1 hour. And we see all the orangey color, which is when arrow pop up, it's orange color.
Right. So it's adding that to the logs where in the logs where it's able to see that error, it's giving it a color code.
Yeah, I really like this one because for people, if they are for our colleague, if they're on call, then they don't have a specific AWS account access. This feature allows them to run query in the first place to find the issue, and we can escalate later.
Right.
Yeah, same thing with the CloudWatch logs insets. The same way to run the query here.
Yes, absolutely.
Next thing is about alerting. How do I configure the alerts? I configure the alerts in the Prometheus, alert rules and alerts, and configure the Prometheus as data source. That's why we can see all these different information here. I will give one of the example. File system is predicted to run out of space within next 24 hours. If this is unhealthy, we will receive a warning alert. So at least give us enough time to fix it.
Yeah.
And if it's running out of in next 4 hours, will be critical. When alerts are generated, we want to get an alert, right? In our case, I integrated with SNS topic and configured my email to receive alerts. In the demo, I will just show a test. We'll receive the send. Otherwise, we'll receive error.
Right.
And you're going to ask, can we use other tooling? Of course. We can also use Alert Manager, PagerDuty, or Slack. These days, PagerDuty are quite handy, especially for our SI team.
Right.
Do you use PagerDuty in your role?
No, what did we used Opsgenie.
Oh, cool. Yeah, also
Yes.
have the integration.
Yeah.
For the silence feature, for example, if the clients have a planned internal maintenance window, we can also silence these alerts in advance to avoid alerts fatigue. And the group feature allows us to group like different service and different environment, group these alerts.
Right.
The last one I want to show you guys is about the tracing in AWS X-Ray. Before I start, I want to give a little bit context. I have deployed a sample application to the cluster, and this sample application has a collector agent running there, which means whenever there's an API call sent to this sample application, all this API call going to be sent to the X-Ray as traces. But how did I send this API call, right? In my demo cluster, I have deployed a traffic generator. So it keeps sending API request to the sample application and get collected and sent to this X-Ray. So we see all these traces. On this web UI, we can see most of the details. If the request sent and respond successfully, we'll see okay. But sometimes if you have error, it will be a red. It's not green anymore. We can see the overview level information here. Let's look at one of the trace. Here we see it's all green. If the request have any issues, it will have the red dot here or the brown.
Christina, question. How would you define what a trace is?
How do I define what a trace is? Trace basically is X-ray is a collector. We configure the collector, the adult collector. So basically, there's a endpoint and sent to the X-ray, AWS X-ray. And in the application, we also in the sample application, we also have an endpoint sent to the ADOT collector. And the collector, there's a port number and the collector able to collect all the API requests and send to X-ray. There's also a trace pipeline, I remember.
Awesome. Yeah, I guess Josie, do you want to add what is X-ray? I guess we didn't really dive too deep in what X-ray might be doing and in terms of traces, etc. Yeah.
Yeah, so traces are a collection of spans and segments which allow you to view the journey of a request end to end. So it gives you the end to end visibility of a request. Now, I think with OpenTelemetry, since you have mentioned OpenTelemetry and the ADOT collector, you are able to have a pipeline to choose where you can specify which of the traces get sampled, because otherwise traces can get quite expensive. So you do get this, there is tail-based sampling that's possible now. So you can sample if a particular request, typically you are looking at the traces when something has gone wrong with a particular request. And so you want to look at those requests which have failed. So you use tail-based sampling where you choose to send to X-ray only the end-to-end visualization of those requests which contained an error in them, either a 400 or took longer than a specific amount of time, or 500, as opposed to sending all traces, because sampling everything or all requests can certainly go up in the amount of money that you'll have to pay with X-ray. But yeah, that's probably something like, I think if you were using the normal CloudWatch agent, the default is it does 5% of sampling. So Liquid Surya has mentioned internals of service, what is broken and needs patching, just like real life. Quite aptly named. Yes, absolutely. I like that analogy. Going to use that next time.
Thank you. Thank you for answering that, Josie and Mai.
I think I like Liquid Surya's more than mine. I think you should take Liquid Surya's explanation of it showing the internals of a service. So like kind of a journey of a request, right? So if you had a request that was hitting a container, so it was hitting EKS, and then it was hitting a service, and then getting that service properly called two other services, and then one of them had a database call in the middle. So it kind of traces that entire request end to end and gives you that visibility, so that you'll be able to figure out where in that request path, handling path, there was an issue. So
yeah, that's right.
Yeah, nice, Liquid Surya.
Yeah, I think it's a little bit similar what I'm gonna say next here. We have the getting started service running on EC2 instance, and here the application gonna have an outgoing API call and call the remote Amazon service. This is how the trace segment details here. Request a URL, and we have the metadata. We also have the trace map. So here the client refers to traffic generator, and the trace basically collect the request from the end user to the end-to-end, basically. And for each request, we can grab all these metrics and request. And if there's any error, it will pop up here as well. And if there's any alerts, it will also show up. But in our case, it's all 200. So we don't have a chance to see the alerts. Yeah, that's it, actually. I really like all you guys' questions.
Yeah, awesome. Thank you so much, Christina, for showing us this awesome demo and talking about observability and EKS. Just one more question before we wrap up. Were there any challenges in setting up the solution?
Yeah, so I think the challenge will be there are a lot of online resource. You got to find what is useful for you and testing. Apart from that, when trying to set up the Cube events logging, I have to deploy event exporter and a vector so that I'm able to push the Cube events to CloudWatch. That part, we don't have a lot of online resource. And in order to push the logs to CloudWatch, we set up an actual IRSA role, which is for the service account. Basically, you have to granularly control which container have the permission to integrate with other AWS service and what's the logic behind. One of the key thing is I think I missed the trusted relationship, and I think there's some like typo issue, but I thought I did, but then you thought you did it correct, but then somehow you just miss the basic ones, and then it caused the issue. Then you thought you already set up the trust relationship, but somehow it just doesn't have the permission. And always the minor things sometimes it blocks your way, I guess.
Yeah, thanks so much for that. One more question from the audience, Liquid Syria. Do you want to read out this question, Jyoti?
Yeah. Is there a way to configure that for a given pod log only at certain log level, like info debug, warning error, and being able to tune it? I'm wondering, is this related to the X-ray sampling, Surya? Was that what you were? Could you let us know in the chat? You probably, because we're not asking this question in the context of the demo at the moment. It's probably, unless Christina, do you get what this question may be relating to? Is there a way to configure that for a given pod log only at a certain log level, like info, debug, warning, and error, and being able to tune it? Was it the X-ray sampling that you were referring to, or? Not sure.
Not sure. I guess we'll find out. All right.
Yeah.
I know we're running out of time at the moment. So thank you so much, Christina. Thank you, Jyoti. It's been a pleasure having you on board today. And we'll see you next time at AWS She Builds Tech Skills.
Thank you, guys. Thank you, Josie. Thank you, and thank you for the questions.
Bye-bye.
Bye.
Bye.